Welcome to the Chapter 4 review video for expressions. We're going to look at 5 problems today. All of them will have very similar questions on the quiz this Friday, and they cover the 6 units that we've done so far in Chapter 4. So the first question is asking us to write an expression. So Julia has $20 in her bank account, then she babysits for $10 per hour. Write an expression that represents the amount of money she has after H hours of babysitting. So let's start. If she works, the answer, we don't necessarily need to do this, but this is going to help us get the answer. If I think about it, if I work 0 hours, right, or Julia works 0 hours, then the amount of money she has is going to be $20, right, because that's how much she starts with. So 0 hours, she has $20. All right, what if she works 1 hour? So if she babysits for 1 hour, she has that $20 that's already in her bank account, and then we're going to add $10, right? Because she made $10 babysitting for 1 hour. If she works for 2 hours, she has that $20 that she already has in her bank account, and then we add $10 for the first hour she babysits, plus another $10 for the second hour she babysits. So we could write that as 10 times 2. She's making $20, 10 times $2, for 2 hours of babysitting. If she babysits for 3 hours, she has that $20 in her bank account, and then she gets $10 times 3 for each of the 3 hours she's working. Right, so this is gonna end up being 20, 30, 40, and 50. Right, but the question is asking us after H hours. So the reason we do this is because we're looking for a pattern to understand what's going on. If Julia works H hours, right, some unknown number of hours, she definitely has her $20 no matter what that she starts with in her bank account. And then she's going to make $10 times that H, times the number of hours she works. Just like when she worked for 2 hours, we multiply 10 by 2. When she worked for 3 hours, we multiply 10 by 3. When she works for H hours, we're going to multiply 10 times H. And this word per, 10 per hours, that's going to signal to us that we have some multiplication going on. Right, so that would be my expression here, 20 plus 10H. That is an expression that represents how much money Julia has after she babysits for H hours. So you're going to want to be able to do this. There's only a few different structures, right? Money going up, money going down if she's spending money. We looked at a few. Look at your notes for 4.1 if you're still struggling with that. But there's only a few types. So knowing this type, knowing those types, you're going to be fine. All right, next question, also from the first unit. 4.1, we want to evaluate 10H plus 20 when H equals 4. So I'm going to rewrite 10H plus 20. And then they're telling me here H is equal to 4. So this is my general expression. I can't get a value right now. That's as simplified as it can go. But they're saying, okay, now H is equal to 4. So that means where I see H, I can replace it with 4. Okay, so I'm going to replace H, which was right here, with 4. And then I keep my 10 plus my 20. 10 times 4 is 40, plus 20, so we get 60. That would be our final answer. And if you see, this is actually the same expression that we wrote for Julia. I switched the order around, but it's the same expression. So this would mean like when Julia worked for 4 hours, when H was 4 hours, this is how much money that she has. She has $60. So again, whenever you see these evaluate questions, you see what our variable is equal to, and wherever you see that variable, you're going to substitute in that number in its place. All right, next we have combining like terms, which we all did really well on when we did it, so you just need a little bit of a reminder. For our like terms, we have like terms if just constants, just numbers, no variables, those are all like terms. And then if we have the same variable with the same exponent or no exponent, those are all like terms. So step number 1 for all of these we're about to do, as I know we know by now, is rewriting subtraction as addition, because then we're not going to make mistakes with our negatives. So I have 4x plus negative 2 plus negative 3x. So that's all good. That's all addition. Then I have minus 4. So minus 4 is the same thing as adding negative 4. All right, at this step, I'm going to find my common terms, my like terms. So here I have a 4x, which I boxed in purple, and I have a negative 3x. Those are like terms because they both have that x, right? So those are the same. We can think of x as like hot dogs or hamburgers. They're the same thing. We can combine those because they're the same. So here I'm going to have 4x plus negative 3x. And then here I have negative 2, which I'm going to circle in blue, and negative 4. Those are like terms because they're just numbers, right? So if they're just numbers, nothing's attached, those are like terms. So I'll rewrite negative 2 plus negative 4. I'm always adding. Combining, I'm always adding. All right, so 4x plus negative 3x is equal to 1x, or just x. And negative 2 plus negative 4 is equal to negative 6. So that would be my final answer, 1x plus negative 6. The 1's not really necessary. 1x is the same as x, so I could get rid of that. Right, and that's going to be my final answer, which is the same as x minus 6 as well. So for those, remember, we're going to rewrite subtraction as addition, and then combine the like terms that we see. All right, next we have expanding using the distributive property. So first step, just like for combining like terms, anytime we see subtraction, we're going to rewrite that as addition, so we don't make any mistakes with the negative signs. So here, I have negative 2, and then within parentheses, I have x minus 4. So I'm going to rewrite that as plus negative 4. And then I have plus 2y, which is great. Already addition, so nothing to change. Then the distributive property says that I'm going to take this number out front, negative 2, and I'm going to distribute it to each of the terms inside the parentheses by multiplying. Right, so I have negative 2 times x, and then I'm going to add negative 2 times negative 4, and then I'm going to add negative 2 times 2y. Right, and that's going to be expanding using the distributive property. And then I can simplify just a little bit. Negative 2 times x is negative 2x. Negative 2 times negative 4 is positive 8. And negative 2 times positive 2y is negative 4y. Right, so then that's going to be my final answer. I cannot combine these any further because x is different than y, and it's different than 8, different than a constant. Right, so x terms are not like terms with, or y is not like terms with x or the constant. So that's as simplified I could go. So I went from here to here by using the distributive property. And these two expressions are equivalent to each other, right? They're the same, they're just in different forms. They look different. But we were going to evaluate them, we get the same thing. And then lastly, we're going to factor, which again is the opposite of using the distributive property. We undo it. So here I have negative 30x minus 10. Step number 1, like with the last two examples, I'm going to change subtraction into addition. So I have minus 10, so negative 30x plus negative 10. All right, the next step is I'm going to find my greatest common factor. Right? So my greatest common factor or my GCF or D. And I really just do this of the positives, but then if I see they're both negatives, I can apply that. So here I really just have like 30 and 10 that I care about finding the greatest common factor of. The greatest common factor of 30 and 10 is 10. 30 is divisible by 10, we get 3. And 10 is divisible by 10, we get 1. Remember, if we don't remember how to do that, and you have a calculator, which you will for the test, right, we're going to click Math, then 2, because that's where we see GCD, which is the same as greatest common factor, and then I would type 30, comma, 10, and press enter, and they're going to tell me my GCF. Okay, so I get 10 as a GCF. But both of these terms are actually negative. I really have negative 30 and negative 10. So I can like factor out that negative sign too. So I'm going to do that. So the number I'm really going to factor out I'm going to factor out negative 10. So I'll take my terms, 30x, and I'm going to divide by that negative 10 that I'm factoring out. Sorry, that's a negative 30x. And negative 30x divided by negative 10 is 3x. Then I have negative 10, and I'm going to divide by negative 10. Any number divided by itself is 1, so we get 1. Alright, so then I'm going to take what I factored out, negative 10, put that outside my parentheses, and I have 3x plus 1 inside the parentheses, which would be my final answer. So again, the steps which you have in your notes: change subtraction into addition, find the greatest common factor, divide each of your terms by that, and then you're going to have that GCF, or that thing you're factoring out front, and the other terms in the middle, in the inside, in the parentheses. I can check that I'm correct. That's step 5. I can check by using the distributive property on this. So negative 10 times 3x plus 1. I distribute the negative 10 to the 3x and the negative 10 to the y. I get negative 30x plus negative 10, which is negative 30x minus 10. So I get what I started with, which means I'm correct. It's worth noting, right, that this isn't the only thing. Negative 10 isn't the only thing I could factor out. I could have factored out positive 10. I could have factored out 5. I could have factored out 2, because all of those are factors of 30 and 10, or negative 30 and negative 10. And then I would just get another equivalent expression like this, which is fine, right? I could do that. It just wouldn't be considered like the simplest form, but you might see that. I won't, yeah, you might see that generally. But one way or the other, you're going to pick some factor, divide each of the terms by it, and then create your new factor term. All right, so that's all we're doing. That is what will be on the quiz. Next week, the quiz is on Friday, and then we're going to wrap up next week and wrap up Chapter 4 in general and expressions next week before moving on to equations. Guys, study, work hard, do your homework.